As we are doing this Databricks kind of preparation, and especially in this Spark orientation, we're having some sort of understandings and learning curve. Okay, so today we are going to talk about adaptive query execution. In what way it is going to help us so as to improve the query execution, and as well as user-defined functions, because we are getting some of the aspects from UDF also. Okay. So before going to enter into the adaptive query execution, let me introduce a few aspects related to execution modes. Okay. So suppose if I'm making use of execution modes, okay, already we have seen, like, the first thing is the standalone execution mode. And second is the mesos. Basically, guys, this mesos is a kind of the cluster manager, Spark by default in the implementation. Actually, in the Spark developer designers first introduced this particular mesos so as to run the appropriate applications on top of the mesos. And then, however, we are having the Kubernetes, and thereafter all these local mode of operation. Okay, these are various kinds of the execution mode. Uh, and one more important thing, guys, if you are referencing, either I can use the mesos or add kind of thing in production. Generally, while learning or while practicing, you can make use of standalone mode. Individually, you can perform the activities. But in production, where the projects, if I want to deploy and all these kind of thing, in production, you can use these kind of thing. And okay, Mesos, Kubernetes, all these things. These are all most commonly used kind of the aspects. And out of these kind of thing, ARN is the most popular one because this particular ARN is having the capability of running the Hadoop MapReduce kind of thing, and as well as I can run the Spark jobs also. There is a part of the specification where you can manage the things, especially as we are talking about the Databricks. Okay, now, so this platform, we typically use the standalone cluster mode. Okay, so the standalone cluster mode is most popularly used kind of the thing. In the standard cluster mode, so we have been allocated with some of the master kind of thing, where some sort of the terminology we're having, Spark master, and then this you can get with the Spark user interface. Okay, so the Spark UI, okay, what it does is just it is providing us some sort of the environment like jobs. Okay, and then you can see the stages information. Okay, and thereafter storage. Okay, and then environment. Okay, environment, and we're having the executor. We're having the executor, uh, and the SQL is also one of the important pathway in the usage, and JDBC, ODBC server, and thereafter structured streaming. Okay, so this is how you can refer the notion of so various components. And again, guys, job of course is a higher abstraction for the running of the applications, and thereafter we're having the stages, and then we're having the tasks. Is the lowest abstraction in the running of the jobs. You can see that. Now, one more important thing is, guys, these executors. Actually, there is one specific understanding because to address the appropriate aspects of the Spark architectures and all these things. Why we are focusing this much on Spark architecture is two reasons. One is if you understand the Spark architecture properly, then you can easily observe how these jobs are getting into the engine and how they are doing. Second important thing is, of course, up to 16 to 17 questions we are getting from the architecture perspective in the database certification. So that is also one of the important aspects where we need to focus on. So let me give you the representation of the high-level physical cluster. So because to understand the advanced query execution, okay, I mean adaptive query execution, let us try to understand the physical cluster arrangement. Okay, so just we are having a driver, and with respect to this particular driver, will be allocated with some sort of executor. And these executors again having the information of the slot. Again, we are having the slot. Okay, assume that we are having this executor. And similarly, if you take another thing, another executor, again there are some slots. And moreover, we are having some other executor. Slot. Okay. Now you observe guys here. So what is the process here? Suppose, and we pretty know that from the beginning, we are saying that we all are running on top of the Java virtual machine. You may not, it's not only the driver, but also these executors and all these slots and all. Now, the point here is this cluster, there exists a driver and which communicates the executor node. That's what we are seeing. And each of these executor nodes have slots which are logically like execution cores. Okay, these slots are nothing but cores of the execution because every CPU, every machine should have some memory or processor where the job is coming into it and it has to perform the activity. And in a way, after running of these jobs, the result should be conveyed to the driver. So it's a two-way kind of communication. The simplest understanding. Now the observation guys here, the very first point we need to observe is, however, driver, okay, allocates task to empty slots. Why we are saying empty slots is because this particular slot is responsible to store the data and process the data. So it has to maintain that convention. So the driver should, the appropriate driver should see that so as to execute the tasks which are all the empty slots. And then, as I said earlier, the slot represents the empty cores, which are actually processing the data. Okay. So the slot which process the data because slots represent empty cores. You know, this slot is nothing but empty core, empty cores, and which are not actually processing the data. Because observe here, guys, there is an analogy which are not actually processing the data. The understanding is pretty simple. If you see, if in the diagram, if you see the slot is the empty slot, I can say the empty core, which is ready to take up the job. And if you are referencing the job submission, maybe suppose if I am taking the data frame and I am submitting some, and after establishing the data frame, maybe Spark dot create data frame, something like that. And what we are doing is PD dot data frame. Assume that we are having some details of employee ELP. Then now this DF is having some employee data. Now I want to count the number of records. Okay, so and then what happens here is at the moment you submit this particular data, the diagram can be represented now like this. I'm having the driver information, and this driver, be with me guys, executor, and I am having the task here. Here also task. Earlier it is something like slot. Now it is task. And thereafter we are having some other executor. Again we are having the task. There may be in this executor I am having the slot. And your third executor also having some slot is in. There is no task assigned by the driver to the executor. Now the point here is that in the diagram you can see tasks and as well as the slots. And all these executors, however, having the communication with the driver information. However, they're having the communication. Now the point, guys, however, the JVM remains same, Java Virtual Machine. There is no difference. Okay, on top of this JVM only, these jobs are running. So now the executor, all these particular corresponding tasks, task is nothing but the driver assign the corresponding task to the empty slot. Empty slot will be converted into the execution, the task orientation. Okay. So similar to that, and from this particular thing, the driver sends the task to the empty slots and the executors. Okay, whenever the driver want to perform some kind of the activity, it is going to contact the executor and it is going to utilize the slot and the slot becomes the task. And once the task is done, they will be converted to slot and can be available to the future application. Maybe the task is completed, then it is turned into the slot. Here also, task is completed, it is turned into the slot. Slot means it is an empty core where the driver can utilize for the task implementation. Simple, na? Right. Now, if you are referencing the life cycle, many a times we have seen, just if you observe the Spark running life cycle, okay, in terms of driver and all these kind of things, this cluster is having some sort of the executors, and these executors are having the cores. Cores just now we have seen the slots information. When cluster is ideal, you are having the empty slots. Of course, this cluster, if it is free or idle, then you will be getting the empty slots. Okay, empty slots. That is one thing. And if more slots are available, then obviously the capacity to run the task there in the rolling fashion. So suppose this is the main important idea, and don't get confused. Slots are fixed, however. It is nothing to do with the tasks. Only the thing is, if more number of tasks are there, suppose we are having 5 slots, we are having 10 tasks. Okay. So first 5 slots will be assigned with the tasks. After completion, again 5 slots will be again with 5 tasks. Soon after completion of this first 5 tasks, then only it is going to compute. And the question is like that: is there any relationship between slot number of slots and number of tasks? Okay, it is not. Uh, don't get confused, friends. If they are asking some number of task slots is greater than or less than or equal to, nothing to do with slots and tasks. Of course, if more slots would be there, more number of the tasks will be taken by the executor and they are going to run. If sufficient number of the slots are not there, then the task has to wait, and once the slot becomes free, then only it is going to execute. Okay, so that is the main important point we need to observe. And apart from that kind of the perspective, and there are certain properties based actually. Like as our initial understanding of the adaptive query execution, which is empowering, okay, the processing of the Spark querying or whatever the things. So if you refer the adaptive query execution, there are certain aspects related to this. I can say this as a Spark adaptive execution. So adaptive is a common terminology, in the programming logics. If I'm using the term adaptive, the code or the concept is adaptive to the appropriate execution. So we are having actually, if you refer the kind of configuration, I can able to set this particular thing like friends. Okay, so the adaptive query property, there exists a property called spark dot conf dot get off. Okay, just you can give the properties spark dot SQL dot adaptive dot enabled. Okay, so it is if I want to execute the adaptive query based kind of thing, and you need to get this particular thing spark.conf.spark.conf get spark.sql.adaptive enable. Then if you run this, it will automatically get the true. Okay, if I want to set this particular thing. Now, one more property is there related to the same kind of thing, that is spark.conf.get. Here you can observe the spark.sql.partitions. Okay, these partitions, and as usual, guys, in our case, we'll be getting the 200 as a default kind of the partitions. Now, with the help of the adaptive querying, just you can manage the process in a better way. Uh, Now, if you refer the properties along with this thing is, if I want to understand where this adaptive query execution is become quite handy, or which is really helping us, there are certain categories actually. Okay, easily you can grasp it. Okay, observe here, guys. Coalescing, post, shuffle, partitions. Now you see, guys. Yes, coalesce is not new for us. Coalesce is a property of reducing the number of partitions. Number of partitions. Most importantly, without any complete shuffle. Without any complete shuffle. So while studying the property of the coalesce, just to be cautious, guys, like there is one more option called repartition actually. Repartition can be used by the developer either to increase or decrease the appropriate partitions. But the most important point is if you are using the repartition, there is a complete shuffle. What is the problem with the complete shuffle? It is incurring the more memory and as well as more kind of the time. Okay, complete shuffle in the sense again it has to rearrange everything and it has to process the appropriate aspects. Okay, and it takes more resources. Whereas coalescing is not like it is not going to by default it is not going to perform complete shuffle. Just it is going to perform the activity. So of without complete shuffle, it is going to reduce the number of partitions. So if you are using the adaptive query, just it is coalescing post shuffle partitions. That means it is not going to perform the complete shuffling. So in a way, you can make use of the convention of better time utilization and space things. Now, one more important thing is, if I'm using the AQE, adaptive query execution, which is converting sort merge join, okay, which is converting sort merge join to broadcast, uh, which is nothing but broadcast join. Friends, here broadcasting is one kind of optimization where if any kind of the join operation, if one of the table is having less number of records, but I want to apply these particular less number of records to multiple tables, I want to join with that. In that particular case, generally, if you are not using the I mean, AQE, adaptive query execution, it happens as usual because generally start image join takes much time friends, and much resources. Whereas if it is, if I am using the adaptive query execution, obviously the start image join will be taken as a broadcast join kind of thing. Okay. And moreover, if you refer the literature of the Spark, Just this start mid join belongs to category of the map side join. Okay, it is performing all the mapping, all these kind of thing. Whereas if you are talking about the broadcast join, okay, so the broadcast join is a reduced side join. Okay, so if I am using the adaptive query execution, then automatically my start merge join will be converted as a broadcast join, which is the beneficiary for simple query execution. Now, another aspect is the third thing is along with the start merge join, I may be having some other possibility that is converting. Okay, not only the broadcast joins, but it may not be possible all times. No? Broadcast join, one important point is if your table is less and it is having the less number of records, then only we'll go with the broadcast join. Otherwise, what it does, what actually does, okay, just you observe converting start merge join to shuffled reduce join, shuffled reduce side join. Okay, shuffled reduce side join. So converting sort mid join to the shuffle reduce side join. So that means if your data is less, then it is picking up the broadcast. If your data is more, then still it has to apply the appropriate join kind of thing. Then it is going to the sort mid join to shuffled reduce join. And that means if I am reducing the shuffle, then I am done. Okay, so then I can able to reduce the timing and as well as utilization of the resources, and it incurs more requirements on the cluster. Okay, and most importantly, the skew kind of the join. Skew join, we are all aware, no? So it is simply optimized skew join where the skewness comes into the picture whenever there is a specific kind of the observation. I can take in a project, okay, just we are estimating the skills. Okay, we are estimating the skills. And these skills involves Spark, PySpark, Scala, and Java, assume that here. Now, out of these particular four skills, these three skills are few skills actually. Few to more or less Spark only. Because your PySpark is variant of the Spark and Scala is of course default programming language of the Spark, and Spark itself is providing us some sort of querying and all these Spark SQL, all these kind of aspects. But Java altogether is a different language. So this is how you can refer the skewness. Skewness in the sense majority of the records are belonging to a particular category. Okay, that's how you can specify the skew kind of the aspects. Okay. So now the adaptive query execution. So the simple aspect is, guys, how I can specify the adaptive query execution is just by enabling this spark.conf.get, and within that we need to enable the property of spark.sql.adaptive enabled, adaptive.enabled, and the Spark 3 onwards we are getting the benefits of the adaptive query. And moreover, this is highly dependent on the partition kind of thing because partitions itself decides okay whether that is a complete partition or a partial kind of thing, whichever. So now the point is what is the benefit if I am enabling the adaptive query execution? The first benefit, of course, coalescing post shuffle partition. Coalesce is nothing but it's not going to perform the complete shuffle. So just it is making use of the convention, like without performing the complete shuffling, it is performing the activities. And coming to the second option, converting sort by join with a broadcast join, okay, into the broadcast join. So broadcasting is a process of if you see the optimization techniques of the Spark, that broadcasting is a technology where we can manage the mapping of the appropriate simple data or little data into all the cache kind of thing. Okay, that broadcast join. So coming to the sort merge, actually this is a map side join and broadcast is nothing but a reduce side join. And the entire aspects of this adaptive query execution are to reduce the number of partitions. and at the same time without complete shuffling. Actually, that is the main important aspect of the adaptive query execution. And coming to the other thing, converting sort made join, which is shuffled reduced side join. Okay, so sort made join either can be taken as a broadcasting or else a shuffled reduced side join, depending on the situation. If the table is containing less number of records, then you can go ahead with the broadcasting. Otherwise, you can go with the shuffled reduced side join. Third thing is the skewness, as I mentioned earlier. Some portion of the data is having heavy span in the table, then in the table or in the corresponding component, then you can go ahead with the optimized skew join kind of the aspect with the adaptive query execution. Some other topic I want to introduce here, guys, which is nothing but we are getting some of the questions from user-defined functions also. Okay, let me try to give some essence of that, which is the UDF. And the main thing, guys, like of course, Spark provides many predefined functionality for us. Not only Spark, but also all the programming languages provide predefined functions. But still, why we need to implement the UDF for the customization? Because all tasks maybe may not be implemented with predefined. Okay, then in that particular case, we have to maintain the customization, and maybe no function okay available for a specific requirement. Okay, in this particular case also, I can make use of my user defined function. Uh, and moreover, usage of the more predefined functions may lead to the readability issue. So in that particular case, also simply I can make use of the convention of using the UDF. But how do I integrate the UDF with Spark? So there is a process called registering, okay, Spark user defined function according to our requirement. So whatever the user defined function, because not all the appropriate aspects may not be coming into the notion of any doubt. Sorry, friends. Okay. So if you are referencing the registration of the Spark user defined function, accordingly you need to develop the UDF, and maybe with Scala or Python or R, you can define a required function. Okay, the process. Okay, how do I do that? And the second important thing, guys, how do I register that? Okay, so register like this, guys. We need to register. I will give you some example also. So just you can make use of Spark dot UDF dot register. Okay, so and this particular registration can be assigned to a variable. Okay, so just we are making use of this property, and we are going to register the UDF. And then next aspect is, guys, variable. Okay, whatever the variable we have used for the registration of the UDF can be used with any kind of aspect, maybe with the select class or maybe with the filter, etc. We'll see some examples also, guys. And while registering the appropriate function, we'll use some name of the function. That name can be used as the in case of the select or select expression. Okay, even I can apply the group by on top of that. Okay, group by, and having like the flexibility remains same, guys. Okay, it follows no matter whether I'm using the UDF or normal kind of thing. Everywhere it is like that only. So assume that I'm having some data frame with me. That data frame contains the orders data. Some orders data I'm having. This particular thing is containing some sort of the date and order ID, okay, etc. All these things. Now what we are doing is generally guys in the date column we'll be having the date 0101. Along with that we may be having the timestamp also longer this kind of thing. Now what I want to do is I want to pick up the appropriate a conversion of the date rather than taking all these timestamps and all. I want to make use of these dates in such a way that instead of this underscore, just I want to put the space. That's all. Okay, simply I want to write the UDF for that. See here, guys, simple. I'm using the date converter, and we are using the how to get that is spark dot. First, I'm registering this, guys, because I need to register the UDF. UDF dot register, and name I'm taking as date convert. This date convert is the name given to the function, and the entire outcome I'm storing in the variable. And then you pretty know, guys, the lambda function, which is a Python based. As I said earlier, either Python, Scala, or programming, I can make use of a native code. And the date I am taking D, and here we are converting the date into the integer of D. Just I am making, if you see the kind of thing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 10 uh, digit this thing is there actually, total length. So starting from the beginning, from the appropriate date and up to the 10 characters, up to the 10th index, and pick up that data, and I want to replace this hyphen into the space. That's it. Hyphen into the space. So now these things entirely available with respect to the DC. Now the DC becomes a function now. Okay, this is a function now onward. What that function does? This particular function converts your date into the integer, and that too, it is not going to reflect your underscore. Rather, it is just giving the space kind of thing. How do I use that thing? See here, I am having the data frame with me. Data frame dot your select class as usual is pretty low and our favorite. And DC is a function now. And as I said, we are adding some order date. Okay, whatever the date I'm having, I'm pushing into this function. And alias, just I want to give another name to that order date, something like that, and dot. Then obviously your order date becomes like this. Earlier it is 2012 1 1. Now it is going to convert like this. Okay, so it is converting into the integer, and then instead of this hyphen, it places the empty space. So your date becomes like this. Okay, so here the understanding is guys how I can make use of my registration of the UDF and how I am utilizing that date converter as a kind of the application. Not only this one, as I said, select we have seen now as a first example. Next example is filter. Filter, we pretty know on top of the data frame, I can apply some sort of the condition. Here, what I can do, df dot, directly we can make use of the filter. So date convert, just I am making use of my order date. Maybe I want to get the orders on 2023, December 31st. Okay, maybe it is like Zomato or Swiggy kind of the orders, and I want to filter only the orders. Maybe on top of that, I can apply some count or something. Okay, this is the applicability of the filter on top of this DC. Maybe group by and having. Let us see that also. The group by option. Okay, so this particular group by option helps us to compute. Okay, based on a particular condition, it is going to tag all the records. So we observe here guys, df dot. This time applying the option of group by. I want to apply the date converter as usual order date, whatever the date I'm having, just I can mention this. And I don't want to keep that name. Rather, I want to place order date like this. Okay. And then if you want to continue to the next line, just you put the dot and slash. So then Spark observes that, oh, this guy is still doing the code. Now I want to get the count of that particular whatever the number of orders I got. Just I want to get that particular count. Okay, count of, and then dot slash. And the next thing with column renamed, because already I got this count value, no, but I want to reflect that, and count I'm using, and I want to place that as an order count. What it does, guys, actually we are having two options. One is with column renamed, and another is the with column. So with column is having higher capabilities compared with the with column renamed. In the earlier sessions also we have seen with column renamed is only useful for renaming a particular column. So here what we are doing is your count value, okay, your count value. Just we are making use of that particular count in terms of order count. Like that I want to mention. So now it is applying the appropriate count notation, all these kind of the conventions. Now, this is one kind of the logic where you can refer the appropriate processing of the data with respect to normal data frame. And at times, guys, there is a possibility of, okay, so with this, we will close the things. How do I make use of Spark SQL? In terms of Spark SQL, can I use the user-defined functions? Of course, you can use. The process is pretty simple. First, you need to convert your data frame into view, create or replace temp view. Okay, now I want to put some name of the table as orders. Now onwards, what you can do is you can manage the convention of see on top of the data frame, you can apply select filter and all these things. Now what we are doing is this data frame we are converted as a table kind of thing. It's a relation. Na? SQL generally expect the relation. On top of the relation, you can perform the activity. Now what you can do is a simple thing, guys. Okay, rather than using select or something, spark.sql directly, and there are quotations, and I mean this single quotes we need to use. So that Spark observes that, oh, this SQL this guy is running. So what we are doing here is my interest is so as to pick up the date converter, or because here one point we need to observe in the registration of the appropriate UDF, we have given this date convert name of the function. Okay, my friends, name of the function we have given. So rather than using DC, because this DC is a variable where I can use with the data frame. But now my interest is I want to use the Spark SQL. So I'm using the date convert. This name I should use in the registration process, whatever the name you have used. So what you can do is just you can make use of select, okay, orders dot star, because orders now rather than using the DF, I can use the orders because orders is a table just now we have created. Now the name just now we have seen a date convert, okay, date convert, and then you can give the order date, whatever the date we are using as. I want to give the alias name. How do I do that, guys? Order date integer. Just we are converting the date into the integer and we are removing the typo. Okay, just we are making use of from orders table. From orders table. Now here itself, our favorite where class. Okay, where your date convert. Okay, again I am repeating the function order date. Okay, whatever is equal to, just as I mentioned, 2023 1 1, like that I want to give, and you can end up this code, and don't forget to give the show. Definitely you have to give the show method, then only it is going to pick up the appropriate information. So as it is, if you observe this kind of thing, guys, here I'm using the df.select variable DC of order date, alias, and I want to use this kind of thing. Whereas in terms of filter, I can directly apply df.filter of DC order date so and so date. Now, if you consider the Spark SQL, first you need to convert the data frame into the table or view, and then you should maintain this Spark.SQL selector, all these kind of the convention, whatever you are having, and accordingly, the pure SQL kind of the syntax. Similarly, the group by option, okay, so and having class, all these kind of the conventions can be directly utilized uh, in terms of the user defined functions. Okay, so this is how you can refer the usage of the uh, adaptive query execution and as well as user defined functions. And earlier we try to observe some sort of the uh, these cluster and executors and all these things. Okay, so let me conclude the session with key takeaways. Meantime, you can use the chat window to share your doubts, guys. Otherwise, just unmute yourself and ask key takeaways. So just you can observe how the driver is communicated with the executor, and each executor is having some slot, and driver assign the task to the slot, the corresponding task. Slot under processing is the task 10, simple thing. This we have seen. Second important thing is the adaptive query execution enablement. Just with the help of spark.const.adaptive.enabled, so that automatically it is going to enable. And there we have seen some advantages. So it is using the coalescing and some sort of broadcast join and some sort of shuffle reduce join. And then latest we have seen some optimized view join if you enable all these kind of the adaptive query. Next, we observe the user-defined function. If you observe, guys, the user-defined function is for the customization. Okay, for the sake of the custom, though we are having the predefined, but still for the customizations, you can make use of the user-defined function. For that, first I need to register the UDF. Okay, within that I am having the variable equal to some spark dot UDF dot register we have done, and then you need to specify the function name. Okay, and then the actual logic. Okay, with the lambda function we have seen that, and directly if you are using the data frame, use the variable. Whereas if you are using the Spark SQL, use the function name. Okay. Next thing is, guys, there is no restriction. You can use the select and filter, group by, having, all these kind of the conventions can be used with the UDF usage. Okay, we are getting some of the questions from these areas also, guys. That's all. And if you're having any doubt, okay, Himanshu, you can have a look. Otherwise, you can wind up. Okay, then. Thank you.